This video is made assuming that you have a fair understanding of how an Angular interceptor works. This is Code with Srini. Let's get started. Caching an HTTP request for GET calls is highly important as it will avoid making an API service calls unnecessarily. An interceptor can be used to delegate caching without disturbing your existing HTTP calls. Angular already have a documentation outlines on these subjects, but the problem here is it is missing the full implementation. The core idea is very well outlined here. So we are going to make use of this core idea and build our very own caching interceptor and cache resolver service. Let's get started by creating our very own cache resolver service. A cache resolver service is a simple dependency injection service that sets and gets URL query strings along with HTTP response. So let's create our class here, and it's an injectable, so it should be injectable. Export class cache resolver service. And it should contain a private variable of a cache or field as a cache, and it should be instantiated with a map class. Map class has a data type of a string and a tuple of date and response object. So let's define them here. It should be a string and a tuple, which is basically a collection of objects in an array, and HTTP response. And next bit is the constructor. And we will be storing all the HTTP response using a key, which is basically act as a unique identifier. The unique identifiers are basically the API calls that we may make. For example, let's assume that you are going to fetch a list of users, right? So if there is going to be all users you'll be fetching, it should be API/v1/users, and that will be acting as a unique identifier, and it will hold the list of responses that pertaining to the API call. Whereas if you're going to search for a username called Jeremy or JEGER, then it will act as a unique identifier, and that string will be acting as a unique identifier. I hope you get what I'm trying to say. We'll be getting in detail as we move along. So let's go to the set part of our interceptor resolver. So this will be a set which will have a key and a value, basically the HTTP responses that you will be storing, and time to live. So time to live could be a number or it could be null. So by default, let's call it as null. We'll do one. Let's log what we are getting through set method. So set cache key and the key. So we know what sort of a unique identifier or the URL that it will be passed through the set method. And the core logic, the time to live, if the time to live is present. So basically time to live, we may set it as a 60 seconds, which is 1 minute, or however number of minutes that you want to store to cache the data. So you can set it through here. So you will be passing the time to live through the interceptor, and if the time to live is present, we have to write a little logic here, which is fairly straightforward. Expires in as new date and expires set seconds, which is expires in dot get seconds, right, plus time to live, right. So here we are describing how many number of seconds that you want our cache to be enabled, to be stored. And finally, we need to store this cache. So this cache set, so the map comes up with a list of methods where you can set, you can get, let's look at it, you can delete, and you can iterate them. You can do various operations with the inbuilt methods that it offers. So we are going to set the key and the actual value. So the key will be our unique identifier, and we're going to set the tuple as well. So tuple, in case if we have time to live, we will be setting at expires in, and the HTTP response will be our value. Fair enough. And in the else part is when you don't have a time to live, we can set it like this, and we can set a null for that, right? So this is the set part. Now we have to move to the get part of the map. In the get method, we have to use our unique identifier, which is a key. So basically we'll be storing based on the key, right? So we'll fetch the stored value if it is there, and if it is not there, we'll be sending a null. So we need to split our data based on the key. So let's call them as tuple cache get and key. Based on the URL get call, let's say v1/user and the query string something else is there. Based on them, whatever that's saved will be fetched and put them in tuple. Now the first check is tuple is not there, then obviously there are no information present whatsoever, and we're going to send the null. And here we will extract our tuple into a date and response, and yeah, constant expires in equals tuple of 0. 0 is the index, because the first index we are saving the expires in the date as the first index, so that's why we are getting the expires in from the tuple of 0. And the next bit is constant HTTP saved response. This will be our second index, which is of 1 in an array, and now. So this now plays a slightly important role here. Using the date now, we're going to check if the expired time is less than the current time. So if so, we are going to delete the cache and then return the null. Otherwise, return the HTTP saved response. So it's fairly simple logic. So expires in, if the expires in presence and it is not null, and expires in get time is less than the now get time, in that case, firstly, we are going to delete the cache, because we don't want to hold these obsolete information in our in-memory cache. So we are going to delete them using the key and return null. Okay, this is first part of our check. The last part is return whatever that you have, like the saved response that you have, and this is pretty much the HTTP cache resolver. The logic is fairly simple. So we are using key as an argument, and we are fetching the stored value of our mapped cache. So the map data object will look like this, and if the cache is null, right, we are going to return a null to the cache interceptor. Otherwise, the cache is extracted in two parts. The two parts is this, the expires in, and the HTTP saved response. And if the time to live is expired, which is this section, if it is expired, then we will return the null. Otherwise, we will return the saved response to our cached interceptor. All the returns, right, it will be handled in the interceptors. So next, the big picture here is creating a cache interceptor. So let's get started with creating an interceptors. Let's create a folder called interceptors, cache interceptor ts. Looks like it's working. Obviously, the interceptor is similar to the cache resolver. They both are services. They both needs to have an injectable, and it is a dependency injection service. Injectable and export class cache interceptor implements HTTP interceptor. So the cache interceptor requires intercept as a property, which is missing. Before that, let's go to the constructor and inject our cache resolver. So cache resolver and cache resolver service. And the next bit is we need to have an intercept as our missing property. The intercept requires a request, which is a HTTP request of any, and next handler, which will be passing on to the next interceptor or completes the interceptor. And obviously an interceptor will return an observable. It could be null or anything, but it should return an observable of an event. Right, so the first part is in our cache interceptor, we are going to cache only the get calls, not the post calls or put calls, because we don't want them to be cached. So we don't want to cache the post calls or put calls or anything that we're going to save. We don't need them. So first bit is we will check with the method. If the method is not equals get, in that case we're going to return, pass on the information, pass on the request to next interceptor. Okay, so that's what this means. We need to get the cache resolver. So we need to get the requested URL from the cache resolver. So the cached response will be from the cache resolver, and we have seen, right, so in the cache resolver we'll be passing on the key. So that key will be the URL. Now in here we need to write a little complicated logic. So if the cached response is there, then if it is present, if it is not null, in that case, so there is a situation where we'll be returning a null and we'll be returning a response. So in case we are sending a null as a return, then we need to use the off operator from the observable and send the cached response if it is not null. We are returning a cached response if the cache is available. Otherwise, we need to write a separate logic. We cannot accommodate everything in this intercept function. So we need to write a separate method called setRequest, where a little bit of logic is played upon using the request and next, and then pass that information onto the return. So since there is no space to write the entire logic here, we'll be extending them into a separate function. Let's call it as this dot set request. Sorry, not set request, it's a send request, and we'll be making use of that in the return statement of intercept. So send request takes in a request and next. That's from the intercept methods. Obviously a rec, which is a HTTP request, and next, which is an HTTP handler. It returns an HTTP event like in the intercept method. All right, so yeah, we have an observable HTTP event. It complies because we are not returning anything here as of now. So let's write a little bit of our logic. So it's a return next handle of request, but before passing on the request, we are going to pipe them. We're going to pipe it, and we are going to tap, which is a sidekick. Using a tap method, we are going to listen to the events. In the using an event, we are going to check if event instance of if it is a response, because sometimes you might get errors as well. So we're going to check if object type is a response. We need to add them in our Angular core. In that case, so this is the actual logic. So if that's the case, we are going to set a request of URL and the event, which is the actual HTTP response. And finally, we forgot a major thing here, which is time to live. Time to live as a constant, which is a constant of time to live as 10. All right, so our interceptors are completed and cache resolvers are completed. We need to create a mini application where we can test this out. Firstly, to understand this, a cache interceptor is just like any other interceptors. Our cache interceptor initializes the cache resolver, which is here, and in the constructor to make the caching mechanism to work. Next, we need to capture only the get calls. So this part is where we are capturing only the get calls. We are checking if it is a get call. We need to introduce a special header called xrefresh. We'll cover that a little bit later. And the last part is where we use the cache resolver to set the actual URL and the response for our caching mechanism. Okay, so this is pretty much it. Now let's build a simple application where we can make use of our caching mechanism. I already have a mini application built, so I already copy pasted all my code to this editor. So this is where all the information I added. For example, the cache resolver needs to be in the provider and the data service, and including the interceptor. Without this information, nothing will work. The interceptors will never work. The data service part, which is basically I'm fetching list of users and the search users and things like that. I mean, we're going to make use of them. So based on this, we're going to get a list of users. So that's what I'm trying to say. So the data service part is done, and finally the the app component where I added some forms. So let me just uncomment them. Immediately we see an issue. So yeah, we are far from building our application. In the app component, we need to have a constructor. In the constructor, we should call the data service. We need a method to handle that will get list of users from the data service. So get users, and this dot we need a subscriber as well, which we forgot to add. So let's add our subscriptions and observables, which will be user. Sub will be our subscription point, and search subscription, and list of users, of course. So I haven't created an interface for this. We need to have an interface for the data model that you are working. So it should have a model, and it should, all your application should be based on that. So that's one best practice that you need to follow. And we need functionality called search users, and in the search users, search user input, which is a HTML input element. We are going to fetch information from the HTML input element, which is a input element here, search input element. We're going to query this. We're going to call this HTML input element First off, let's see what this search input element returns so we can track. And the next thing is there is a checkbox called, I introduced a checkbox called latest check, which is basically if I want the latest results to be updated, not the cached one, I can check this box. So it'll come in handy sometimes in your application. So I just added them for convenience reason. Latest boolean, but there is an error. We need to import HTTP client module for, right, let's ignore this for now. I'm going to open up a console. That way we will have a clear picture of what's going on. So we have the interface application and all the errors cleared and the application is up and running. So when we type in, let's say JER, which is short for Jeremy, and I'm getting the value here, which is from the console. And the way it operates is I have a button, which is this search button. And on the click of it, I'm calling a search users with a search user interpret template variable from this text box. And also the checkbox that you see is from this code is from here. So the get latest results checkbox, when I click on it and search for it, it will turn to true. So the logic is if you want to get the latest information from the API, it will avoid the caching mechanism and then it'll get it from the server. We need to have a little check. It's purely it's purely optional. We don't have to stress on this. So if the search input value of the length of the search input value is greater than 0, only then we have to make a call, otherwise we don't have to. So I'm going to empty the users array and the search subscription, this data search users search input value. I'm passing on the value that it requires, and yeah, the other value is the latest check. The latest check functionality will never work because we haven't implemented them in our cache mechanism, and we will be covering that soon. So let's complete this flow first. In the subscribe block, we will have a next which will give us the results users to. We need to see what results we are getting. So user list of users, and this users equals users. Yeah, from HTTP response, so it is expecting an explicit. Right, so next one is the error in case your application crashes or the server doesn't work, console.error. And finally the complete, so I'll just copy from here, search completed. Right, pretty much our application is completed. If I search for something, I should be getting the cache key that we have seen in our cache interceptor. Looks like I made a minor mistake. I added interceptor outside the app folder, which should be inside, and in the interceptor we should also fix this. Yeah, now it's all right. Right, so let's begin with our testing. Right, let's do a search here. So if I type in Kim, it goes for a call, and in your console you will see the search is made and there is no result for Kim. Let's try another one. We have a list of users here, so let's try for Will. So there is a Wilford Prince, and in the network, if you see, the search is made for Will, and this will be considered as your unique identifier, the entire URL string. So let's do little testing on this. So if I search for JER, Jeremy, it will give out our result. And again, if I do a test, the API call won't be triggered, but it will return the information from the saved resource, saved cache. And there's one little thing that I forgot to mention in the interceptor part, where we set the time to live. The time to live is set only for 10 seconds. So after 10 seconds, if I do a search, it triggers, right? So this needs to be extended. So for the testing purpose, let's keep it as 10 seconds. But in your real world application, you should decide on how many number of seconds that you need to have. We have searched for JER. Let's search for another name called Will. So Will, and if I do a search again, it won't happen because it didn't cross the time to live of 10 seconds. Now again, if I do a search, it triggers a new API. So far we have seen how an interceptor is used to do a cache resolving here. The other bit is we haven't looked upon using the getting the latest results system, right? This is not yet done. So that can be done using our data service, which is over here. So based on the latest, right? So we are going to send whether the information we need is a latest or not using the flag that we have seen. For example, in the console, you might have seen false, and if I click on them, if I check on them, you'll be seeing them as true. So that information, right? So that is intercepted over here, the latest check, and that will be passed on to our data service as a latest check. And in the data service, you'll be having a boolean called latest. So what I'm trying to say is we can append that information. We can check that information using the latest, and I can set a custom header. It's already been set here, so I'm just trying to explain. If the latest is true, I'm setting a header called x refresh as true. So this information is enough for us to catch them in the interceptor. Over here we can write a little logic that bypasses all the other functional logic here. We can have a check here that says, not here exactly, just above the cached response, that says if request of headers, and I'm going to get if x refresh is present, right? Otherwise this will be true if the x refresh is present. In all of the cases, this won't come through inside this block. In the x refresh, I'm going to return the fresh request. It won't be a cached response, so I'm going to bypass this cached response entirely altogether. So it'll be this part. There you have it. I think this is pretty much it. Now let's test this out, and as a test, I may need to increase our time to live, let's say for 1000. So I'm searching Jeremy, okay, and if I do a search, nothing happens again. But if I click the get latest result, it should trigger an API, which it does. So yeah, that works now. And that's pretty much it about the HTTP caching interceptor. The entire app, or this mini app, will be available to you. I will be providing a link in this video in the description. Please take a look at it and make use of it. In conclusion, this video outlines only the basic principle of HTTP caching technique. Our caching mechanism is really bare minimum and simple. However, if you refresh the browser tab, the stored values will be removed. So what I suggest is we can extend the cache mechanism by saving them in a local storage and making them persistent. We can create a separate service, injectable service called storage service, and we can handle all the storage mechanism in a separate service. In a really large application, we can make use of local storage, and we can make use of a very efficient storage system. So this is pretty much it for the Angular HTTP cache with Interceptor. Thank you for watching this video, and welcome to Code with Srini again. Please subscribe to my channel and share it with your friends. Thank you, and if you have any other suggestions, please drop down that in my comment sections, and I will have a look at it and probably respond to you as soon as possible. Thanks again. Bye bye.